Alright, let's talk about Lewis structures now. A Lewis structure is just a sketch or a diagram that shows how atoms are connected in a molecule or a polyatomic ion and how the valence electrons are distributed among the atoms. Okay, valence electrons means the outermost electrons. So when atoms share electrons, they just share the outermost electrons. Okay, those are called valence electrons. So if you draw something that shows how the atoms are connected and how the valence electrons are distributed, then you have what's called a Lewis structure. Specifically, to draw a Lewis structure, you need to draw dots, okay, to represent valence electrons. So each dot represents a valence electron. Or you can use a dash or a line, which would be equivalent to a pair of dots. So instead of drawing a pair of dots, you can just draw a line. Okay. Now, electrons that are shared by two atoms are drawn between the symbols of the two atoms. And then, if you're dealing with a polyatomic ion, okay, then you have to enclose the entire structure, the entire sketch, with brackets, square brackets, and indicate the charge as a superscript outside the bracket. Let's illustrate that. Here's an example of a Lewis structure for a molecule called urea, right here. Okay, how many valence electrons are shared? Okay, let's see. There's one pair, two pairs, 3, 4, 5, 6, 7, 8. There are 8 lines, 8 pairs that are drawn between symbols. 16 are shared. Okay? So pairs that are drawn between symbols are the shared electrons. How many are not shared? 8. This one is a pair of dots. That just belongs to the nitrogen. It's not shared with the other atoms. Okay, so 2, 4, 6, 8. Those are called lone pairs. Okay, so you have 8 unshared electrons. Okay, 4 lone pairs of electrons. Now, if we have one pair of electrons shared between two atoms, we say that those two atoms have a covalent bond between them, or a single covalent bond between them, or a single bond. If two pairs are shared between two atoms, we say two atoms have a double bond, or a double covalent bond. And if 3 pairs are shared between two atoms, then you say you have a triple bond. And like I said earlier, an unshared pair of valence electrons is called a lone pair. So in the structure shown here for urea, I identify single bonds, double bonds, and lone pairs. What would you call this one?
Single.
This one?
Single.
This one?
Double.
That's a double bond. That's a single bond. And that's called a lone pair. Okay? Now, Lewis structures is meant to show only how the atoms are connected and how the electrons are distributed. If you want a more realistic picture of what a molecule might look like, you need to look at 3-dimensional structures. Okay, 3-dimensional representations, because a Lewis structure is just a flat thing. And there are 2 kinds of 3D structures that you might find commonly used. The one is called the ball and stick model, and the other one is called the space filling model. Okay, the ball and stick model shows how the atoms are connected and in three-dimensional space. Okay, so atoms are represented by balls, and then the sticks show you how they're connected to the other atoms. And then the space filling model, okay, just shows you the boundary surface where you're going to find the atoms, electrons most of the time. Okay, so if you want to look at examples of those on the internet, you just do a Google search for space, let's say space filling model. Let's say if you want a water molecule, here's a space filling model of a water molecule. Okay, so this is called a space filling model of a water molecule. Okay. Now, if you're interested in a ball and stick model, here it shows you Hydrogen, hydrogen, oxygen, and there's a stick between those two between the atoms that are bonded together. That would be a ball and stick model for molecules. Okay? And if you go back here earlier, what would you call this type of model right here? That would be the Lewis structure. You have a line representing shared electrons, dots represent two dots representing a pair of electrons. This is what type of model? Space filling. And this one, that's a ball and stick model.